Especially
What is a power series? Well, I'm going to try to get to the Lagrange there. Okay, guys, shh. What's a power series? It's a series where all the terms are made up of powers. So it would be like this: C0 plus C1x plus C2 x squared, etc. This is centered at the origin. So you build it at the origin. Well, yeah, we're going to do those. Trust me. Okay, all of our series, girls, all of our series are power series. If it's a Taylor, Maclaurin, it doesn't matter. Okay, so we have the geometric one. Matt, do you remember what that is?
Yes. Find the sum of X.
No, this is this 1 plus x squared. This is one you have to memorize. X cubed. And this is x to the n. Let's get them all down here. This is 1 over 1 minus x. And the interval of convergence is 1, negative 1 to 1. And the endpoints are not going to converge. When in doubt, do the endpoints.
Yeah.
I'm not really sure. Okay. Now, we'll talk about what a Taylor series is in a second, but let's get the power series for e to the x. This is centered at the origin. E to the x looks just like this, but it's 1 plus x plus, then it's x squared over 2 factorial. Remember that? Plus x cubed over 3 factorial. So to me, this is how I remember it. It looks like the geometric one, except it has the factorials in it. So it's x to the n over n factorial. Okay, what are the other two we have to know?
Sine, cosine.
Okay, so the sine of x is, it's an odd function, so the powers are going to be odd, and they alternate in sign. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. You could always derive it because it's not that bad. And then it's x to the what? How do you get an odd number? 2n plus 1. As long as we're starting at 0. If you didn't start at 0, you'd have to fix this, but we're starting at 0 over 2n plus 1 factorial. And the cosine, oops, I forgot my negative 1 to the n. What's the cosine of x? It's an even function, but not only that, it's the derivative of the sine. Okay, so can you see the board because with the light now?
Yep.
So if I took the derivative of this, it's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And then it's going to be negative 1 to the n. Does that work? Negative 1 to the n?
Yeah, that's good.
Yep. N is 0. If n is 1, I'm here. Okay. And it's x to the what?
X to the n.
No. If you take the derivative, you put 2n plus 1 over 2n plus down here on the top. So it's 2n plus 1, and then it's 2n plus 1. What's the one right after it? You subtract 1, so then it's 2n factorial. So it's going to be 2n, because these are going to cancel, and then it's going to be over 2n factorial. Got to get even numbers. Okay, is that okay?
Yeah.
You have to memorize those. So actually the last 2 years were gifts. They were so easy.
So that means
We'll do them. We'll do one.
Let's do it.
Not necessarily will be hard. Okay. Yeah, those are the 4 you need to know. I've never seen you needing to know the log one.
What'd you say?
Why?
No. What did he say?
She's just lying.
See what he said. Say it in the video.
Okay. So what I try to do is use the geometric and some relative of the geometric. Like I could take the derivative of this, or I could integrate this. If I integrate this, I'm going to get the log. And that's how I can generate a whole bunch of power series. But the problem is, what about e to the x and sine of x? I can't get those. Not out of the geometric ones. So there's probably other functions out there that you can't get out of the geometric ones. These families. And so you could do e to the x squared, now that I know this. What would e to the x squared be?
Substituting your x squared for all those terms.
Yeah, substitute in x squared for x. So this is x squared squared over 2 factorial.
What about some really nasty functions?
You could always do that, but
It'd be a lot of work.
it'd be a lot of work. Over n factorial. So you can find a power series for any function. It's just not easy. Like the one a few years ago was the sine of 5x plus pi over 4, and you had to take the derivatives to do that because it wasn't centered at the origin. It was not pretty. Okay, so we have Taylor polynomials and we have Maclaurin. Okay, guys, so when we do these Taylor series, or the Maclaurin, and these are centered at A, although they use the words interchangeably. So they may have a Maclaurin series where they can call it a Taylor series, or they may call it a power series. So don't worry about that. And the Maclaurin series, we always hope we have this, because that's always easiest, centered at x equals 0. And how do we find these other series, these other power series? Do you remember what the Taylor polynomial was? Well, we're going to center it at A, so it's f of A. And I'm going to write out, there's 3 pieces to each term. Even though the other pieces here are 1, I'm still going to write it.
F prime of
So it's x minus A to the 0 over 0 factorial.
1 for some reason.
So this is by definition. You can call it whatever you want, but it works nicely. Plus the first derivative at A, x minus A to the first power over 1 factorial. And again, I don't have to write those ones, but I'm just doing it to make a point. What's the next one, Justin? F double prime of A, x minus A squared over 2 factorial. And so the nth one, and if you had done the project, this would have made sense to you. Where do these derivatives come from? Too many people have copied it. The nth derivative at A, x minus A to the nth power over n factorial. Now it's hard for them to ask you to find derivatives because it's time consuming. That's the reason why they give you things and then ask you to do other things with them, and we'll look at one in particular. So A is going to be 0 if we're talking about Maclaurin series. And what do you mean by centering at A? If I want to estimate e to the 9.1, I'm going to do my Taylor polynomial centered at 9. It's like your tangent line approximation. When you have a curve, and where are you going to, if you want to find this value, where are you going to draw your tangent line? Not down here, are you? You're going to be really close to that point so that this little distance here is very, very small. So that's why you do your derivatives at different places. Then the series will get closer and closer to the actual sum faster. I certainly can use the e to the x series that I have and use 9.1 in it, but it's going to take a lot of terms for me to find that value. So we don't want to do that. We want to be within, we want to be able to only have like 2 or 3 terms, because that's what you do in the real world when you use Taylor's polynomials.
Should we know what the graphs look like for like most of these functions?
E to the x and sine of x, yes.
For like ln of x and
Yes, you should know what ln of x looks like. Okay, here's another thing. If they ask you for the 10th derivative, for instance, at A, you can find it if you have the Taylor polynomial. Because the 10th term would look like this. Let's write it up over here. It's the 10th derivative times x minus a to the 10th power over 10 factorial. Okay, so if I want the 10th term, I'm sorry, the 10th derivative, okay, Kevin? The 10th derivative is not just the coefficient.
Just set them equal to each other.
Right. It's not the coefficient, it's all of this. Oh, yes, I forgot that.
Texas man.
Sorry. So what I do is I take this over 10 factorial and I set this equal to C10. Actually, it's probably C10. The coefficient of the 10th term. And we'll get into problems that do that. Okay? Well, you can also find the first derivative, because where's the first derivative? It's the coefficient of x minus a. So if the first derivative, if this term is missed, then that means the first derivative is 0. And if the first derivative is 0, then we have a candidate for maximum or minimum. And how do we do that? We do the what test? Second derivative test. So let's look at the cosine function. Oops. If I look at the cosine function, we know that there's a maximum at 0, right? Okay, guys? There you know what cosine looks like. That was one in our project. So it looks like this. We already know this, but... And what's the coefficient of x? It's really 1 plus x. It's going to be, no, it's 0. Right? Because there aren't any there. So f prime of 0, because it's the center at the origin, is equal to 0. How do I know if it's a max or min? I do the second derivative test. Do you remember the second derivative test? Because I'm going to test this. Well, I know what it is. Okay, so I look at the second derivative, which is negative 1 over 2 factorial. That's equal to f double prime of 0 divided by 2 factorial. This is the coefficient, right? So what's f double prime of 0? Negative 1. The second derivative is not 1 over 2 factorial. This is the fourth derivative is 1 over 4 factorial equals 1 over 4 factorial. I think I said that right. So anyway, this is negative. So that means my function is what? Concave down. So therefore we have a max. Don't just draw the picture. Say concave down. And the more problems you do, the better. And you have a packet. I don't know where my old extra packets are, but you have a packet of all the Taylor polynomials, including the Form Bs, from back when we did Chapter 8. One other thing, since we're here, and then I'll show you how to do it, and I'm going to try to keep this pretty simple. These are the first n terms. So f of x, well, we'll call it a, minus the absolute value of that, minus the sum of the first n terms is less than or equal to, and this is the Lagrange error bound, sum of the first n terms. So this is the first term. What's the next term after that? Whoops. Be that way. So it's f n plus 1 of a, x minus a to the n plus 1 all over n plus 1 factorial. And it's just like, well, it's not quite just like, but it's pretty close to the alternating series estimation theorem. Remember how the error was less than the first discarded term?
Sure.
Yes, the error is less than the first term you don't use. So if they ask you for the third degree polynomial, you will then go to the fourth term, the fourth degree term. It's very similar. The difference is I have to have a maximum here. This is supposed to be the maximum value. You'll see in a second. Whereas that's not quite true. It's not going to be a derivative when you do the alternating series test. It's probably a 1 or something. So this is going to be less than or equal to, the error is this, n plus 1, and it's the maximum value of that one at a So usually it's a sine or cosine, because I don't know what the maximum value is. What's the maximum value for sine or cosine? 1. So it could be just 1. Now, if you write that down and you try to put the numbers in, showing that you've been exposed to the Lagrange error, you might get a point. I'm not going to guarantee it, but you might get a point. So let's do a problem that has us do that, and I'm sure I'm probably forgetting something here. So what do we have for the x squared part? X squared, if you factor out x squared, you're left with a positive 1 minus 1/2. So you factor out these. Then you just add the coefficients. That's why we do add the coefficients always. Okay, so I'm going to remember this because I think I need this for the other part. So we're at 6 points right now. I think this is 2. No, I think this is 1. And it says find f, the sixth derivative at 0. So f, the sixth derivative at 0 over 6 factorial is equal to the coefficient of this term with x to the sixth, which is minus 121 over 6 factorial. Correct? That's what we had to multiply it out. But you really didn't have to add similar terms. You could have left it. You didn't have to factor x to the sixth out.
Why is it only? Oh, you can just think it's 2. What if you put the 2 factorial? Would that be wrong?
What 2 factorial?
For the 1 plus x squared over 2.
No, that's right. Question, Kyle?
On C, you should have something after that.
No, it's not something.
No.
Sixth derivative of 0.
Well, because then this is x to the sixth, and this is x to the sixth. So those, what happens to those? If you like to do that, go ahead and put them in there and cancel them out.
Yeah, can you show how do you add them up?
I'm totally
Well,
feel like this is
let's,
easy. Don't you just
let's do it. What is the sine of x squared? Because I don't have enough room there.
go back to the
x squared.
I didn't cancel anything.
Factor an x squared and
Sine of x squared was what? Tell me what this is.
negative 1 over 2 factorial.
Over what? Plus, is that it? Is that all I needed? Yeah, we don't need that one.
Why?
Because it said only the first 4.
Yep, but no, add up.
But we're going to add it to the cosine. Okay, what is this? Plus x to the 10th over what? 5 factorial.
Minus x to the 14th.
Okay, so what's the cosine of x? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, right? I know, that's why I didn't even want to write the 10th down, but you guys wanted me to, so I did. So I'm going to add the first 4. There's 1, then we have an x squared, we have an x to the 4th, and x to the 6th. So I'm just going to add those up. That's all. Didn't ask you to simplify.
So you can just, why is sine of x squared? Isn't that only 2 terms or what?
I want a total of 4 terms.
to match up with the x.
Read the directions.
Maybe it's C just negative 1.1.
Yes. It says write the first 4 non-zero terms for cosine. We did. Use the series and the series for sine of x squared to write the first 4 non-zero terms of the Taylor. I've been giving you the answer for C.
No, no.
Oops, I don't want to go
Is it x squared plus 1? Is it that one term?
there. Say what?
Is it x squared? Like, look at sine of x squared, right?
Right.
The first term is x squared. The first term of cosine x is 1. Isn't the first term for the whole function x squared plus 1?
It's 1. X squared plus. So it says the sine of x squared plus the cosine of x equals. I think you're making this hard. It's not hard. Equals what? Just add those.
Squared plus 1.
In order doesn't matter, but do a favor for the graders. Plus 1 plus x squared from the sine of x squared minus x squared over 2 factorial from the cosine.
That's 3 terms, I think.
No, these can be combined. It's only 2 terms. This is 1 term, that's 1 term. Let's get it written out. Plus x to the 4th over 4 factorial minus x to the 6th over 3 factorial minus x to the 6th over 6 factorial. So that's where your problem is. The term is determined by the x's. So if I factor out x squared, I'm left with 1 minus a half. And I don't have x to the 4th. There's only one of those. And if I factor out a minus x to the 6th, I get 1 over 3 factorial minus 1 over 6 factorial.
Oh, okay, I got it.
Okay, they didn't tell you the degree of the polynomial. Oops, thank you.
And then what do you do next?
Then we add those. That'll give you your points.
I got it.
But now they're asking us for the 6th derivative at 0.
So you can just leave it in that form.
Yes.
But if you want
We have to simplify to do the next piece, I think. Well, even if you don't want. Because this is equal to, now that's x to the 6th. Okay, guys? Matt? This is equal to the coefficient of x to the 6th, which is 1 over 3 factorial plus 1 over 6 factorial x to the 6th. What happens to x to the 6th? Doesn't go to 0. It cancels out. You divide it out. So that I get the 6th derivative at 0 equals 6 factorial times this. Could you leave it? Oops. No, it asks for the 6th derivative. Let's see. 6. Terms are determined by those powers. So you have an x to the 0, you have an x squared, x to the 4th, and x to the 6th. There could be more fractions added on x to the 6th if we added another another series to it. Yes?
Is it 1 over 3 factorial minus 1 over...
No, I pulled the negatives out. Right here. They were both negative. So if I distribute that, I'm just thinking this might be an easier way to do it. It's 6 factorial over 3 factorial plus, and it's 6 factorial over 6 factorial plus 1. And that's 6 times 5 times 4 times 3 factorial over 3 factorial plus 1. What don't you get?
I don't get how you pull out the 1 minus 1/2 and that type of stuff.
I just factored it. I took this and I found the common factor of x squared. That's x squared times 1. That gives me this one minus 1/2. Distribute that. That gives me that. And what can I factor out of this? I took out a negative x to the 6th.
Okay. Well, why does x to the 4th over 4 disappear?
It doesn't.
Does it?
It's still there. It's right there. No. And now I'm missing my negative sign. There's a negative sign here. I almost missed that, but I knew it was negative. And so this whole answer is negative. And what's 6 times 4 times 5? The 3 factorials go, there's a negative. So I didn't have to do fractions, did I? Negative 121. Because I had factored out the negative a long time ago, right here. It's a matter of keeping track now. Yeah, so did I. It's, I believe, 1 point. So, you know, well, that's what I have to teach you. How do we do D? That's the Lagrange error bound. Okay, so let's go ahead and look at this. And it's not that as bad as you might think. And it says...
Wait, so is the P of the 4, is that what we found?
That's the first 4 terms of a polynomial.
Can we use a calculator on this?
Nope. You don't need it. That's not what it's asking.
Oh, so you just plug in 1/4 into the F of 4 then.
You don't even have to do that. Thank you. It says let P4 be the 4th degree Taylor polynomial. So that's for this function, which is not the 6th degree, but the 4th degree. Where is that? So it's just this. And now remember, and this isn't, it's not an alternating series, but the test is similar to that. I'm going to use this as my first discarded term. for my Taylor polynomial. Okay, we said that was,
Doesn't have the answer, right?
so it's 121 over 6 factorial, right? Oops. Where's my question? Okay. If I do this right, so it's using the information from the graph. Here's the Lagrange error bound. We are doing P4. So what's the next term? It's P6. So I want to get the sixth derivative, the maximum at my point. Where's my point? 1/4. That's what's a little bit different. And then it's x minus 0. So it's 1/4 minus 0. Let me write it out. It's x minus 0 to the 6th over 6 factorial. What's my x value there? It's not 0. Yes. So it's the 6th derivative. And if you write this, then that's 1/4 minus 0 to the 6th power. If you even write that, I believe you're going to get your point over 6 factorial. And you want to show that that's less than 1 over 3,000.
There's 2 points.
It's 2 points. So 1 for knowing it's Lagrange error bound. Is that okay? Because we're not going to do this at 0. We're going to see how far off we are. Just a little bit of a distance from 0. So when I read my graph here, what's the maximum error do we have here? Oh, it's P5. Whoops. Did I do that wrong? Yes, use the graph. Right now. But I have this wrong. It's the 5th. We have to use the 5th because this is the derivative we're going to use. That's the 5th derivative.
We're doing the 4th degree.
Then they want you to, it says, using information from the graph of the 5th one. So, I didn't read very well, did I?
Miss G.
Oh, but it's going to be very much the same. What's going to be, if I use the 5th derivative, what would that term look like? It would be the 5th derivative at 1/4, the maximum value times 1/4 minus 0 to the 5th power over 5 factorial. I know it doesn't make sense to me that we'd be using 5. That's the reason why you did 6, but we'll look at the answers. And then what is the maximum value? I said, how in the world do I do the graph? But it's at 1/4. So all you have to do is find a number that all of these are less than. They're less than what? 40. Could you use 38? Probably. But I want nice numbers because I don't have a calculator. So this is 40. That's what this value is right there. And then it's times 1/4 to the 5th, and you have a 5 factorial here. And I don't know if they make you multiply that out or not. Whoops, 1 over 3,000. Let's see if I did it right. I'm pretty sure I did. But that's the part I kind of missed. Form of the error bound. It's the maximum value of the 5th derivative between 0 and 1/4. There's 5 factorial and 1/4 to the 5th. The only way to know it's less than 1 over 3,000 is to multiply that out. And shall I show you how to do that without a calculator? Because I don't think you know how to do that.
Just do 1 to the 5th and 4 to the 5th.
Yeah, what's 4 to the 5th? But I wouldn't do that, though. I would reduce, because I don't know what that is. So I've got 40. That says 5, 4, 3, 2, 1. I don't need that. And then if you want to do it this way, it's 2 squared to the 5th. So it's 2 to the 10th. Right? Well, 2 to the 10th is 2 to the 5th times 2 to the 5th. What's 2 to the 5th? If you're going to go into engineering, you're going to be doing lots of stuff with 2's. 32 times 32. Then because it's 2 to the 5th.
I mean, like, why do it?
Why do they do it in engineering? Because all your computer programming is in base 2. Or hexadecimal, one of the two. Okay, so let's go ahead and simplify what we can. 5 5 goes in once, goes in 8 times. 4 goes in once, goes in twice. What else? 2's cross out. So I'm left with, in the numerator, a 1. And then this is 3 times 32 times 32. What? Well, that's why I said, you want me to show you how I reduced? 5 goes into 40 8 times. 4 goes into 8 twice.
Oh, so you
The 2's cancel.
better.
So maybe I would make it 96 times 32. Do you guys remember how to multiply?
Yes.
I forgot. Can you explain that 40 times 43?
Oh my God. Oh, you're serious.
Okay,
Where'd you get that? 2 times 32.
because 2 to the 10th, you could do 4 to the 5th. But 2 to the 10th
Oh, because
is 4 to the 5th. And I know what 2 to the 5th is. I'm trying to keep my arithmetic down to as little as possible. But it's only 1 point.
1 point for
To
all
do the
time?
calculation. No, to do the Lagrange error bound, to do that.
But they give you 3 points for just spitting out something.
Because this is hard.
But wouldn't they want to give you more points for them? Since it's so much harder.
Remember, the average was 5, which is very unusual. So let's do 2010. And we will finish. No, it isn't.
That was a fast
That
question.
is. That was good, fast.
Because we didn't start on time. Your homework is to do the 1997
Just fast.
multiple choice.
What I haven't done 2003 yet.
You're behind. How many class periods are left?
7.
6.
6 now.
Okay? Work on that and work on Taylor polynomials. So tomorrow is kind of question answer. There's a study session at my house on Sunday from noon till 6. Come anytime. I'm available noon till 6. It doesn't mean you come for 6 hours. You come when you can. And I make my famous brownies.
Are we doing any stations this week?
We're doing study sessions Tuesday, Wednesday, Thursday if necessary. You guys can let me know. You guys, you're not supposed to go yet.
Hey, you gotta